We'll wait 2-3 minutes for others to join and then start. So, hello guys, welcome back to the lecture. I hope you remember, good evening all. I hope you remember last lecture we completed parabola. So, from now we'll be starting with ellipse. Just a second, guys. Yeah. So now today we'll be starting with ellipse, and in the coming days we'll complete ellipse and then start with parabola. So our plan for today is to go to the basic various forms of ellipse, the basic definitions that we studied in parabola. The same we are going to study in ellipse. There might be some change, not in the definition, in the equations, obviously. So let's start. Welcome back, everyone. Let's start. So here, as you can see, in previous classes, that means in your physics class, I think, or not in physics class, in 9th standard, you have been studied that the Earth rotates around the Sun in an elliptical orbit. So the path that Earth follows while revolving around the sun, sorry, not rotating, revolving around the sun is elliptical path. So I hope you know what does an elliptical path looks like. If not, let's see what the elliptical path looks like. But before that, I hope you know how do we define a conic. Conic is defined as locus of a point which moves in the plane so that the ratio of its distance from a fixed point. This fixed point is called focus and its distance from a fixed line. This fixed line is called the directrix. So that means here what are we trying to say is this is P, any point whose distance from focus, which is SP, upon its distance from the line directrix, which is PM, is in a constant ratio, and that ratio we know is known as E. E means eccentricity. Yeah. Let's see what we want. Just a second, I'll enable. Yeah. Yeah. Chalo. So this is the same diagram as you can see. Now the constant ratio, as we know, is generally denoted by E and is known as eccentricity. And we have discussed in previous lectures also that eccentricity of ellipse is less than 1, while eccentricity of parabola is equals to 1. So this is the focus, which is S. Z, Z dash is the directrix. P is any point on ellipse. And what is the definition of ellipse? SP upon PM equals to E. This we already saw. Is it clear, guys? Give me a thumbs up. All good till here? Girisha? Okay. So let's see what we have next. That means if we cross multiply, I'll get SP is equals to E into PM. So the equation of the ellipse in standard form is x square upon a square plus y square upon b square equals to 1, where a is greater than b. Correct? And b square is equals to a square into 1 minus e square. Now, as you know that in parabola, we had four standard parabolas, right? So we had four different equations. Similarly, in ellipse, we have two standard ellipse, of which one of them is this, where a is greater than b, right? And b square equal to a square into 1 minus e square. This is a relation between a, b, and eccentricity. Now let's see, define the terms. I know you know the, like we have defined the terms like focus, directrix, axis, vertices or vertex, latus rectum, etc., etc., etc. in term for parabola. Same thing we'll be doing in ellipse. Let's see. What are the MCQs? The fixed point in the plane is called. What is the fixed point called, guys? Chalo, write down in the chat box. We have studied done just now. The fixed point 2, superb. It is called focus. The fixed line, it is called fixed line. It is called directrix. Superb. 1. Right? So this was just basic MCQs. You know, we have this pattern. Next. The conic section is said to be ellipse if its eccentricity is. Come on. Eccentricity should be for an ellipse equal to less than 1. Super. If it's parabola, it is equal to 1. If it's hyperbola, it is greater than 1. Right? And if it is 0, that means it's a circle. We don't need to know about circle. We need to know only about parabola, ellipse, and hyperbola. Chalo. What is the general equation of ellipse? What is it? Come on, just now we studied it. x square upon a square, superb, 1 plus y square upon b square equals to 1. They should have written a is greater than b, but it's fine. It can be either. Let's see what we have next. So next we have nature of the curve. Now nature of the curve is very important when we'll do curve tracing. That means in your calculus part. But here I just want you all to understand some basic points which we use in nature of the curve. Here we also will be defining the other standard ellipse and other standard results. Let's see. This is the equation of ellipse. Let's see with the curve represented by this. Okay, we define C as this curve. The curve is symmetric. How do we know this now? This is important. How do we know the curve is symmetric? About the coordinate x. The curve is symmetric about origin. Now let me tell you, the curve will be symmetric about x-axis. The curve will be symmetric about x-axis. Yeah, the curve will be symmetric about x-axis if in the curve we replace x by minus x. If we replace x by minus x, does the equation of the curve will change? No. The equation of the curve will remain the same. That means the curve is symmetric about y-axis. The curve is symmetric about y-axis. Similarly, to check whether the curve is symmetric about x-axis. Yeah, same, because square of negative number is positive. Superb, Girisha. Right. If we want to check symmetric about x-axis, what we do, we put y is की जगह पे minus y. Now, is there any change in the equation if we put y equals to minus y? No, the equation remains the same. That means the curve is symmetric about x-axis. So this is how we check the curve symmetric about x-axis or y-axis. Now the curve is symmetric about origin. This we will learn when we study calculus. Okay. So let's see, origin is the midpoint of every chord of the ellipse. What that means is, see, this is the shape of the ellipse. I hope you know what is the shape of the ellipse. Yeah. This is the shape of the ellipse. Now, as you can see, from origin, the curve is symmetric. That means distance from origin on both the sides is same. Right? Yeah. So that means every chord of the ellipse through origin will be bisected at origin. As you can see, this is a chord which will be bisected at origin. That means this distance will be equal to this distance. Similarly, every chord will be bisected at origin. That means origin is the center of this ellipse. Chalo, what we have next? This we already saw. Put y equals to 0 in the equation of ellipse. Now, what does it mean by putting y equals to, just a second. Yeah. What does it mean by putting y equals to 0? Y equals to 0 means we are getting the x-intercept. Y equals to 0 means we are getting x-intercept. Right? From straight line, we know to find x-intercept, put y equals to 0. So that means x square will be equal to a square. That means x equal to plus minus a. That means the curve, these are the x-intercept. That means the curve meets x-axis at 2 points, which is a comma 0 and minus a comma 0. As you can see, the curve cuts the x-axis at a comma 0 and minus a comma 0, which we represented by a and a dash. Also, you can see here there is a new word which is principal axis. So x-axis is called the principal axis for the curve where A is greater than B, right? So the ellipse has two vertices. I hope you know the definition of vertices. What are those vertices? They are A and A dash. Vertices were the point of intersection of the curve with axis. Line segment pass through origin. What does that mean? You are saying some definition? Line segment pass through focus is called principal axis. No, principal axis is not line segment passing through focus. Acha, okay, I got it. You are already on foci. We have not defined foci till now. It's fine. Super. So according to you, it's correct. Very good. So two vertices, A and A dash. Okay. Next we have A dash is called major axis, or as we can see, it's called principal axis. And the length of the major axis, as you can see, this length, this distance is A, this distance is A, so the total distance will be 2A, right? It is 2A. Now, similarly, if we put x equals to 0, we get y equal to plus minus b. That means the curve intersects the y-axis at 2 points, which is 0, comma b and 0, comma minus b, which we represented by b and b dash, as you can see here. Now, this axis b dash is also called the minor axis. X-axis was called the major axis. The y-axis in this case is minor x. What will the length of minor axis? 2b, because this is b, this distance is b. This distance and this distance is b. This total distance is 2b. So the focus of the ellipse. Now we will define the focus. And as you correctly said, the axis or the focus lies on the principal axis. Let's see. This is the ellipse. This is the center origin. Here is the focus. The focus lies on the x-axis, right? So there are two foci. One is S and the other is S dash. As you can see, S and S dash is image with respect to minor axis. That means they are equidistant from origin. So if coordinates of S are AE comma 0, then coordinate of S dash will be minus AE comma 0. I hope it is clear. Excuse me. Second focus, S dash is called the second focus. Okay. The directrix of the ellipse. C equals to A. Very good. You are running very fast. That means I think this you have completed this in your school, right? Grisha, this is completed in your school, right? That's why you are giving answers. Super. The equation of directrix is x equals to a by e. Now, how the equation of directrix is x equals to a by e? Let us see. So, with respect to the two focus, this ellipse will have two directrix. One will be with respect to focus S, and one will be with respect to focus S dash. So with respect to focus S, the directrix is x equals to a by e. And the mirror image in the y-axis will be x equals to minus a by e. Right? So these are the directrices. Chalo, double ordinate. I hope you know the definition of double ordinate. What is a double ordinate? It is a chord which is perpendicular to the axis. That's what we have been seeing. Chord passing through point P on the ellipse and perpendicular to the major axis. So this is perpendicular to the major axis. That means this is known as the double ordinate. Double ordinate. Next we have focal chord. What is focal chord? Any chord which passes through focus is called the focal chord. So a chord on the ellipse passing through either of the foci. So here we have two foci. That means if a chord passes through either of the foci, it's called focal chord. Yes. If the latex rectum, I think you're wrong. No, beta. The ordinate or this one, double ordinate, which passes through focus, is called the latex rectum. We'll define it, then you'll understand. You are very close. So there are two things, a double ordinate and a focal chord. Double ordinate is perpendicular to the major axis, whereas the focal chord passes through focus. Now, if a chord satisfies both the conditions, that means it's a double ordinate as well as it's a focal chord, then that is a specific chord which is known as latex rectum. So latex rectum is both. It's a double ordinate as well as it's a focal chord. So let's define focal chord. We have already defined. Let's see here. This is a chord which passes through focus. Therefore, it is a focal chord. Latex rectum. Now, this is what I am trying to say. A latex rectum is both a double ordinate as well as a focal chord. So a focal chord of the ellipse perpendicular to the major axis. So this is the focal chord because it's passing through focus and it's perpendicular to the major axis. That means the principal axis is called a focal chord. Now since we have two focus, there will be two focal chords. One on S and one on S dash. Sorry, there will be two latex rectums. Right? There will be two latex rectums. Chalo. If the latex rectum meets the ellipse at L and L dash. So let us name those points. Let this point be L and this point be L dash. Then L dash, that means the length of latex rectum. That means the length of latex rectum. It's called length of latex rectum. Superb. Two b square by a. Superb. Very good. The length of latex rectum is 2b square by a. Yes. Chalo. We'll derive the length of latex rectum. Yeah. Same thing we will talk about here. Now, the length of latex rectum of this ellipse. Just a second. Yeah. The length of latex rectum of this ellipse is 2b square by a. It is 2b square by a, as Girisha correctly said. Chalo. What is the proof? So let this be the latex rectum. Let us name it L and L dash. We already know the coordinates of focus. What is the focus of the ellipse? What is the focus of the ellipse, guys? It is AE comma 0. That means this distance is AE because the coordinates of S are AE comma 0. And let's say the length SL be of L distance. Then if we know the coordinate geometry, then you can easily guess the point of capital L. What is the point of capital L? It will be AE, comma L. AE, comma L. Now, we need to find the value of L. We need to find the value of L. So, as you can see, this point L lies on the ellipse. That means it should satisfy the equation of ellipse. So what we'll do, we'll substitute this point in the equation of ellipse and get the value of L. Let's see how to get L lies on the ellipse. Substitute the point in the equation of ellipse. So if we substitute it, we'll get like this. A square, or we can use distance formula also. How we can use distance formula? For distance formula, we need 2 points, beta. We don't have the coordinates of L. If we have the coordinates of L, then we can use the distance formula, right? Understood? Yeah. So here, A square and A square will get cancelled. We'll be left with E square plus L square upon B square equals to 1. Now, we know that E square or B square I can be written as A square into 1 minus E square. That means what will be 1 minus E square equal to? 1 minus E square will be equal to B square upon A square. So I can write 1 minus E square as B square upon A square. Correct? So if we solve this, L square upon B square equal to B square upon, so I'll get L square equal to B raised to 4 upon 2. If we take under root, we'll get L is equals to, this should be L. L is equals to B square upon A. So that means the coordinates of L will be AE comma B square upon A. Now let me bring the diagram again. If this length is L, this length is also L. Then L dash is the length of lattice rectum. And if L is B square upon A, the length of lattice rectum will be 2L, which is 2B square upon A. Right? We want this length of lattice rectum. Let's see what we have next. The coordinates of the 4 ends of the lattice rectum. Now, as we all know, the ellipse is a symmetric figure. That means whatever the coordinates we get in the first quadrant of lattice rectum will be same, just we have to adjust the sign according to the quadrants. That means in the first quadrant, of L as AE, comma B square upon A. So what will be the coordinates of L dash? L dash was in the fourth quadrant. So just adjust the sign according to the fourth quadrant. So in fourth quadrant, Y is negative. So we'll get minus B square upon A. Similarly, these are the end points of lattice rectum drawn on the focus S. Similarly, we have a lattice rectum drawn on the focus S dash. Let's see what they will look like. Oh, sorry. Let me erase it. Yeah. Yeah. So we got the coordinates of L. Similarly, just adjust the sign. See, in the first quadrant, both are positive. L dash is in the fourth quadrant. So X is positive, Y is negative. L1 is in the second quadrant. So X is negative, Y is positive. That means the coordinates are same. AE, B square upon A. Just adjust them according to the quadrants. Let's see what we have next. the MCQs. Let's see how you can give correct answer. The latus rectum, length of latus rectum. I think Grisha already said, right? 2. Superb. It is 2b square by a. The coordinates of end points of latus rectum in the first quadrant. It will be very simple for you to answer. What will it be? 2. Correct. Because in first quadrant, both should be positive. Equation of directrix. This is interesting. Do you remember till now? In the standard form, that means which form? X square upon a square plus y square upon b square is equals to 1. So what is it? What's the answer? Achha, you don't remember? It is x equals to a by e. Do you remember the diagram? This was ellipse, this is latus rectum, this is latus rectum. Its equation of this was x equals to a by e. It is parallel to the y-axis. That's why its equation looks like x equals to a by e. Distance between foci. This looks interesting. Come on, what is the distance between foci? Two AE. Yes, superb. It is 2AE. Now, various forms of ellipse. As you know, we had 4 forms of hyperbola. Or we can say 4 standard forms of hyperbola. Similarly, as I told you before, there are 2 standard forms of ellipse. What are they? The first one is x square upon a square plus y square upon b square, where this condition is important. A is greater than b and both are positive. Hyperbola 2 or 4. What does that mean? Hyperbola will discuss it after the ellipse. Standard form. A hyperbola also has 2. Only parabola has 4 forms. Hyperbola and ellipse both have 2 standard forms. 4? No, parabola. Achha, by mistakenly I said hyperbola. Okay. Parabola has 4 standard forms. Ellipse and hyperbola have 2 each. Sorry, my mistake. Yeah, thank you. Chalo. So one of the standard form of ellipse is x square upon a square plus y square upon b square equal to 1, where a is greater than b. And both are positive. What does this mean? Both are positive. Both are greater than 0. Let's look at the shape. It's the same shape we have been studying till now. Center is at origin, vertices are A and A dash. Foci are S and S dash. It is also known as horizontal ellipse. Correct. Now, the second form. Eccentricity. How do we got the formula of eccentricity? We know that b square equals to a square into 1 minus e square. So if we calculate eccentricity from this, we'll get the formula of e. No need to remember, just remember this. B square equal to a square into 1 minus e square. What were the equation of directrix? X equal to a by e and x equals to minus a by e. You can combine it together to write x equal to plus minus a by e. Equation of major axis. Here the major axis is the x-axis. So its equation is y equal to 0. Minor axis, y-axis. Length of lattice rectum we already saw 2b square by a. Let's look at the next standard ellipse where a is less than b, but both are greater than 0. That means both are still positive, but a is less than b. So this is also called the vertical ellipse. And you can see it looks like this, vertical. It just looks like now everything will be with respect to y-axis. That means the principal axis will be y-axis. Let's define the terms. Center will be 0, 0. Vertices are this now, B and P dash. The coordinates obviously remain the same. Foci. Now, foci will be on y-axis. That means their coordinates will be 0, b, 0, minus b. Next, eccentricity. Now, in this case, eccentricity is, what was the first case? B square equal to a square into 1 minus e square. So, in this case, it is a square equals to b square into 1 minus e square. Please note this. In previous equals to, it was b square equals to equation of directrixes. Now, since the focus is on y-axis, directrix will also be perpendicular to y-axis. So, y equals to b by e and y equals to minus b by e. If you are seeing everything or every formula may a is replaced by b. In every formula, a is replaced by b. That is a single difference. There and x is replaced by y. So there it was x equals to a is replaced by b. So here we get y equals to b by e. So this is, I'm giving you this way for you all to remember the formula. It will be very easy for you all to remember the formula. Here the major axis is y-axis, which is x equals to 0. Minor axis is x-axis. Length of lattice rectum. See, as I told you, replace a by b. So it was 2b square by a. Now it became 2a square by b. So these were all the standard results you need to know. I hope it is clear. In standard division also x square upon b square. No, no, no. It is not hyperbola. It is same. See the equation? Just this condition is changed. One of the form is a greater than b and other as a less than b. The equation remains the same. See, x square upon a square plus y square upon b square. In both the cases, the equation remains the same. What is the change? The change is just in the values or in the values of a and b. Got it? So now we have MCQs. Chalo. For the ellipse, here please remember B is greater than A. That means it is the second standard ellipse. Distance between foci it is asked. As per our logic, just replace A by B. So first it was 2A, now it will be 2BE. Superb, Grisha. Next, for the ellipse, distance between directrix. So this looks interesting. Distance between directrix. No. What were the two? 2b by E. Superb. It is 2b by E. Very good. Because in the first case it was 2a by B. Just replace A with B. Got it? Chalo. For the ellipse, the major axis is B is greater than A. What is the major axis? No, no. Beta, major axis is y axis. But its equation is x equals to 0. Equation is given. Yeah. Got it. Superb. For the ellipse, equation of directrix is what is the equation of directrix? It is y equals to b by e. Y equals to b by e. Next, the standard results. I hope you know that we have gotten the same standard results in parabola as well. So first thing is position of a point, tangent, and then normal. So the position of a point is same as parabola. That means the point can be on the parabola, it can be inside the parabola, it can be outside the parabola. So mathematically, what will give whether the point is inside the parabola or outside the parabola? If P lie on the ellipse, then S1 will be equals to 0. If P lies inside the ellipse, then S1 will be less than 0. Inside means less than. And if P lies outside the ellipse, then S1 will be greater than 0. These are the three cases. Very simple. Not many questions are asked on this. The main thing is the next part, which is the equation of tangent to the ellipse. We know that tangent at point P x1 comma y1 is t equals to 0. What does t equals to 0 means, guys? T equals to 0 means replace x square with x1. What is x1, y1? x1, y1 is a point. And replace y square with y1. So if I do this in the equation of ellipse, I get the equation x1 upon a square plus y1 upon b square minus 1 or equals to 1. Simple. This is the equation of tangent to ellipse at point P x1 comma y1. I hope it is clear. T equals to 0 we have directly used. Give me a thumbs up if it's clear. Girisha, hello. Is it clear? Yes or no? Hello. Give me a thumbs up if it's clear. Super. Chalo. Next thing, what we need to know? The equation of normal is this. How did the equation of normal came? Yeah. What was the equation of tangent? It was x1 upon a square. Sorry. x1 upon a square plus y1 upon b square equals to 1. What is the slope of tangent? It is minus coefficient of x, x1 upon a square upon y1 upon b square, which is b minus b square x1 upon a square y1. This is the slope of tangent. We know that tangents and normal are perpendicular to each other. So what will be the slope of normal? It will be a square y1 upon b square x1, negative reciprocal. Now, what is the point? Point is p x1 comma y1. So if we use the slope point form, which is y minus y1 is equals to m into x minus x1. If we cross multiply and simplify, I think we'll get it, right? Let us check. So if we cross multiply, I'll get b square x1 into y minus b square x1 y1 is equals to a square y1 into x minus a square x1 y. So let us group the terms of x and y. So I am taking uh, this term and this term. I'm taking on right hand side. So I get a square yx minus b square x1 y is equals to the rest of the terms on the left hand side. So a square x1 y1 minus b square x1 y1. So I can take x1 y1 common and I'll get a square minus b square. So if we divide by x1 y1 on both the sides, so what we'll get? A square y1x upon x1 y1 minus b square x1y upon x1 y1 is equals to x1 y1 a square minus b square upon x1 y1. So here x1 y1 will get cancelled, here x1 will get cancelled, here y1 will get cancelled. So finally, what equation do we got? We got a square x upon x1 minus b square y upon y1 is equals to a square minus b square. This is my answer, which was the same equation here. So I hope it is clear the equation of ellipse. So today we'll be stopping here as time is already up. We'll now be continuing with ellipse in the next lecture, which is on a Thursday. So Thursday we'll be continuing with more theory part, the chord of contact, tangents, pair of tangents, the parametric form. So these parts we are still left to cover. We'll cover that in the next lecture and then start with MCQs. So till then, bye bye everyone. Take care. Thank you all. Bye bye.